When bonding a cold water pipe, it's essential to understand the requirements for effective grounding. You only need to bond the cold water pipe at the nearest location of the service entrance. This means you should connect the bonding jumper from your grounding system to the cold water pipe as close as possible to where the water pipe enters the building or where the service equipment is located. Jumping the meter, meaning running the bonding conductor all the way back to the water meter, isn't necessary. The purpose of bonding is to create a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse quickly in the event of a ground fault. Bonding at the nearest location achieves this goal effectively. Here are some key considerations when bonding a cold water pipe. Firstly, the size of the bonding jumper must be appropriate for the size of the service entrance conductors. The National Electrical Code (NEC) provides tables that specify the minimum size of the bonding jumper based on the size of the service conductors. Consult NEC Table 250.102. Secondly, the bonding jumper must be securely connected to the cold water pipe using approved methods such as bonding clamps or lugs that are listed for grounding purposes. Make sure the connection is clean and free of corrosion. Thirdly, the cold water pipe must be continuous and electrically conductive from the point of bonding to the point where it enters the earth. If there are any insulating couplings or sections of non-conductive pipe within the cold water piping system, they must be bypassed with a bonding jumper to maintain electrical continuity. This is often required where plastic, such as PVC or CPVC pipes, are used. Fourthly, if the building steel is used as a grounding electrode, ensure it is properly sized and connected to the grounding electrode system. Refer to NEC Section 250.52 for requirements on grounding electrodes. The connection to the building steel should be made with a suitable bonding jumper. Fifthly, the ground rod should also be properly installed and connected to the grounding electrode system. The ground rod should be driven into the earth to a sufficient depth to ensure good contact with the soil. Typically, this means driving the rod at least 8 feet into the ground, unless rock bottom is encountered. Sixthly, all connections in the grounding and bonding system must be made using approved methods and materials. This includes using listed connectors, properly tightening connections, and protecting connections from corrosion. Seventhly, it is crucial to inspect and maintain the grounding and bonding system regularly to ensure that it remains effective. Check for loose connections, corrosion, and any signs of damage. Correct any issues promptly to maintain the integrity of the grounding system. Eighthly, consider that supplemental electrodes might be needed. Depending on the soil conditions and local requirements, a single ground rod may not provide adequate grounding. In such cases, supplemental grounding electrodes, such as additional ground rods or ground plates, may be required to improve the effectiveness of the grounding system. Ninthly, ensure proper documentation. Keep records of all grounding and bonding system components, connections, and inspections. This documentation can be helpful for future maintenance and troubleshooting. Tenthly, when working with electrical systems, always prioritize safety. Energize the circuit before making any connections or modifications to the grounding and bonding system. Use appropriate personal protective equipment, PPE, such as insulated gloves and safety glasses. If you are not comfortable working with electrical systems, consult a qualified electrician. 11thly, always comply with all applicable codes and regulations. The NEC provides comprehensive requirements for grounding and bonding electrical systems. Local codes may also have additional requirements. Be sure to familiarize yourself with these codes and regulations and follow them carefully. 12thly, remember that bonding and grounding are essential for electrical safety. A properly installed and maintained grounding and bonding system helps to protect people and equipment from electrical shock and fire hazards. By following the recommendations outlined and adhering to the NEC and local codes, you can ensure that your electrical system is properly grounded and bonded. 13thly, consider the function of grounding in relation to surge protection. While grounding provides a path for fault currents, surge protection devices, SPDs, protect against voltage spikes and surges caused by lightning or other transient events. SPD should be installed in conjunction with a properly grounded electrical system to provide comprehensive protection. 14thly, understand the difference between grounding and bonding. Grounding connects the electrical system to the earth, while bonding connects conductive parts of the electrical system together to create a low impedance path for fault current. Both grounding and bonding are necessary for electrical safety. 15thly, regularly test the grounding system. Periodic testing of the grounding system can help to identify any potential problems or weaknesses. Use a ground resistance meter to measure the resistance of the grounding electrode system. The resistance should be within acceptable limits as specified by the NEC. 16thly, if alterations are made to the electrical system, such as adding new circuits or equipment, be sure to re-evaluate the grounding and bonding system to ensure that it remains adequate. Any changes to the electrical system can affect the performance of the grounding system. 17thly, consider the type of soil in your area. The type of soil can affect the effectiveness of the grounding electrode system. Sandy soil, for example, typically has a higher resistance than clay soil. If you have sandy soil, you may need to use longer or multiple ground rods to achieve adequate grounding. 18thly, if you are unsure about any aspect of grounding or bonding, consult a qualified electrician. Grounding and bonding can be complex topics, and it is important to have a thorough understanding of the requirements to ensure that the electrical system is safe and compliant. 19thly, note that improper grounding and bonding can have serious consequences, including electrical shock, fire, and equipment damage. It is essential to take grounding and bonding seriously and to follow all applicable codes and regulations. 20thly, keep in mind that the information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult a qualified electrician for specific recommendations regarding your electrical system. The intent is to provide a comprehensive understanding of the principles and practices of electrical grounding and bonding, emphasizing the importance of safety, compliance, and proper installation techniques.